Couchbase 103, talking about views and indexes. We're going to talk about, what views are, how you query them, what are the typical queries you do, what are the structure, the architecture, etc. So you understand, indexes and views in Couchbase. Um, and like Franco said, we are doing Couchbase 101 again. For those of you who are joining us for 103 but haven't seen 101 or 102, we'll be doing starting that over again next week if you're interested in joining. And we have a lot of things to cover, and I do want to show the interface demo, so I'm going to go ahead and get started. And welcome to Couchbase, and here we go. So the first thing to understand is, what is a view? Views are indexes, and indexes are methodologies. They're ways of finding data. I mean, we see them every day in our lives. If you've ever gone to the library back in the day, it was the card catalog before it was digital, and you used computers to look up things. You used a card catalog because instead of sifting through books, you could use a system like alphabetical order, or you could use a category or subject matter. The Dewey Decimal System was another type of index system. In computing, indexes are very similar to that. It's methodologies for finding data. And views in Couchbase are indexes. They're ways of finding data. In relational systems, it's the same concept. It's a way to find data fast. And I think the fast part is in particular for Couchbase and relational systems. It's a way to find particular data items fast based on key attributes. You tend to index certain fields that you're going to be looking things up by. So if you're trying to find users by email address, you create an index on that email address so you can find that record very quickly. Indexes are specialized structures for searching for data. So unlike just data storage itself, it's a specialized structure that is optimized for searching quickly. Often you've got multiple copies of the same data, some in an index and some in actual general data storage. So indexes are, ways of finding data quickly. Indexing subsystems are often separate pieces in database systems. They're not the storage, and storage might have its own threads that are managing storage and retrieval, and then indexes are its own set of threads. That's often the case to optimize performance. That they're actually separate systems. Storing data and indexing data are separate processes. And that's also important to understand for both relational and for Couchbase and NoSQL, is that these are often separate systems. They're working together. As an application developer, you don't see that they're separate. You just see this interface. For relational, you're using SQL queries, and to you, it's transparent whether they're separate systems or not. You can't tell. And the same goes for Couchbase. These systems are integrated. Our storage and indexing systems are integrated together. However, the way you query is through views. You're querying indexes, and then your binary operations that we covered in Couchbase 102 are, getting and retrieving your CRUD operation, storing and retrieving your data directly through binary operations. So you're kind of working with both of these subsystems, more directly. In flexible schema scenarios, and this all applies also to Hadoop installations and any type of unstructured data or semi-structured data, MapReduce is a technique that is used to create indexes. In relational system, indexes are based on the column's static data type, the schema itself. So the indexes will be optimized for the data type that is being indexed, whether it was a numeric or it's a string, or so in those type of scenarios, they'll create a data structure that's an index for those columns that you are specifically creating an index for. In semi-structured data, or where data can vary in structure from row to row, in our case it's document to document, MapReduce is a general technique that is used in these types of scenarios. It also allows for parallelization. MapReduce was a technique designed to allow you to process and index data that is distributed across many different servers and can be run in parallel in batches and groups. And that's basically what Hadoop is doing, over humongous data sets. In Couchbase, um, uh, so as I was saying, the MapReduce is a technique, right? So in Couchbase, this is specifically done for indexes, and this is where Couchbase and Hadoop will differ. Hadoop is for processing large amounts of data. It actually allows you to nest these MapReduces into multiple hierarchical jobs. For instance, if you're going to process genetic data and you're looking for a pattern within genetic data, a chromosome pattern or gene pattern, and a huge amount of genetic data, Hadoop is designed for that. It's a slow, long-running type queries where you're kind of analyzing data. Couchbase, it's a little bit different. These are the MapReduce technique is being used, but it's being used to create an index, and so it's generally optimized to be faster, and it's not hierarchical or nested. So it's a single level MapReduce. A map function is basically a function that identifies data within a collection, processes it maybe minimally, and then also outputs the transform value, and that value in Couchbase is what is going to be indexed, and you'll understand more about that later. Reduce functions, correlate to the map function in that they take the output value and they might, you create aggregate calculations from them. It's generally for numeric data that you're outputting, and you're basically reducing that data by creating statistical or aggregates on that data. So Couchbase is a MapReduce technique used to create indexes. So as you can see in this diagram, your CRUD operations are creating, documents or modifying documents. They get pushed to, the map functions that you have defined. And as the map functions are processing those documents, it will emit or output data that is organized into an index. So our indexes are on disk as well, and they are B plus trees. They are tree structures, and they are optimized for searching. So there's a lot of optimizations actually within that for reduces. It'll keep track of aggregates lower in the tree by propagating reduces up to higher nodes, so it makes it much faster to process reduces and things like that. But these are a specialized second data structure on disk that is an actual index, designed for query. So this is important to understand, that you're also storing documents on disk and you're creating these index, which are an independent structure on disk as well. And you'll understand why later when I talk a little bit more about the anatomy of the view and you understand the sort of the structure of what's happening in a MapReduce. So here's a sample MapReduce, map function in this case. And in this map function at the top, it's written in JavaScript, and it's very simple. We're creating, the document is being passed and the metadata is being passed for every single document that is being, every single CRUD operation that creates or updates a document will pass through this map function. So it'll send the document itself and the metadata. The metadata has the document key. And so in this case, we're saying if the doc.type, and doc.type means the JSON key, within the JSON, the type field, if that equals beer, and it also, the doc.brewery ID and doc.name are non-null, emit or output the name of the beer and the alcohol by volume of that beer. So what we're doing with this map function is filtering. So if we have a doc type that says is a user document, it'll be ejected from this immediately, based on that if statement. So it won't emit into this index. So I'm creating an index here of beer names and alcohol by volume. And anything that doesn't match that if statement, if for instance I have a beer in there that doesn't have a brewery ID, or somehow I got data in, I didn't have error checking in my input form, and somehow someone submitted a beer without a name, it would not actually end up in the index. So this if statement is basically a filtering on documents. So every document passes through, so if it doesn't match that if statement, it won't get to the emit statement and it won't be included in the index. So let's talk a little bit about the architecture of the view engine. So from storage to index, so we've got our application server, and it's doing storage operations into Couchbase. Immediately it gets into the RAM cache. Then it goes to disk write queues and replication queues. It gets written to disk, and then after it's written to disk, the indexers in batches will process them, send those documents to the map functions that have been defined, and index the ones that have been emitted or added to the index. This is incremental, so we'll have an index already existing, so we'll either be modifying that index structure or we'll be adding more to it. Whether it's an update operation or it's a create operation, we'll be modifying it. I'll show this animation one more time. So storage operations immediately go into RAM cache, disk write queues, it gets on disk, then it goes to indexers in batches, and the indexers will process them, and update the index on disk. So eventual consistency in indexes. So your data model is consistent. So when you create a storage operation, we'll call this time 1, and that's your RAM cache. You can immediately do a get, and it's reading from the RAM cache. So you have data consistency. What people who are new to Couchbase or new to this or new to views often get stumbled upon is the eventual consistencies of views. So views come in and get updated after it gets on disk, goes to the indexer, and then it updates the index. Then those results will show up when you query the view at time 2. So there is a time gap, and this can be extremely short, but there is a time gap between time 1 and time 2. It has to get on disk first, and then indexed, and then it's in the index. So views are eventually consistent. Your data is consistent. Your views and indexes are eventually consistent. And often new developers stumble upon this, and I'm going to show this animation one more time because it's very important to understand this. Storage operations go immediately to RAM cache. Your get operations will read that write immediately. And then it'll go through disk write queues, get on disk, and the indexers will index it, and it'll end up in the index at time 2. So there is a small time gap there, and it is under control as to when that happens and how often that happens. And we'll talk a little bit about that. So why use MapReduce indexes? First is to find documents by different JSON values. So if your keys in your documents are email addresses and someone logs in with their email address, you can find that document easily. But what if you want to find documents by their zip code, people's zip code? You want to find out all the users that live in 94101. Then you're going to need to create an index of users by their zip code. So you create a map function that looks for user documents, and if they have a zip code, stored, if they've entered in their zip code, you're going to emit the zip code, as an ID, the first part, and we're going to go through the anatomy of a map function next. And you're going to emit the zip code as an ID, and then you can basically you can count them, you can do aggregate, you can do a reduce where you can have the number of people that are in that zip code. You can also look up, you'll have the document ID for each one of those, so you'll actually be able to iterate through the users or however you want to use that. So you're creating an index on zip code. Now, if you want to create an index if you want to know all the users that are, in California, you can create an index on California, on the state. And so you're creating another map function that creates an index as I want to quickly find all the users that live in California. So you create a map function to do that. So you're creating an index of all users, in California. So then you can query, these documents based on different JSON values. Now, if one particular user has not entered in their address, they won't show up in the index, right? So from document to document, this is the reason it's different than, say, map functions, is that the null values won't show up in your index. And And that's actually a good thing, because then if you have data that varies, you want to find all the users. Let's just say we want to find all the users that are missing their zip code. We can create a map function that looks for all user documents that has a null value for their zip code and say, oh, these are all the people that haven't entered in their address. And the next time they log in, I want to know that, and therefore I want to, identify them or send out an email, update your address for 5 points or whatever it is. So there you can create indexes for null values and non-null values. You can also create statistics and aggregates on these users. It's a way of analyzing your data as well. You can look for missing information. There's a lot of different ways you can use these indexes. If you're actually updating your documents, you want to add a new field. You're creating a new feature and you want to add a new field to all the documents. You can create an index for all the documents of a specific type that are missing the field, and then use that to iterate through those documents and create that field, through a cron job or something like that, to create a job to modify documents. And you can use the views to actually create an index of the ones that have not been transformed, for instance. Indexes are necessary when you also have a document key that is unpredictable, meaning if you're not using someone's email address as the user document key, you're using just a UUID, you're not going to be able to guess that from their login. So you're going to have to use views. You're going to have to create an index to be able to look someone up by their email address if the document key is not their email address, for instance, and you use a UUID instead. We talked about that a little bit, about key value patterns in Couchbase 102, and I think for certain things it's very important to use key value patterns because it makes things faster and easier, especially for the largest, the largest collection of any application tends to be users, unless it's going to be log data or some sort of analytics data, which would be the highest volume. But when you're talking about primary data, users or products and things like that, it tends to be users being the highest volume, in which case key value patterns and immediate consistency is important in that case. But if you are using, unpredictable keys for things, views are a way of getting to those documents. So the anatomy of a view, and after this I'll take a few questions. So our views are organized in what's called design documents. So design documents are namespaced within a Couchbase bucket. So here we have views defined within a design document. In this case, I have 3 views, 3 different MapReduce functions defined in this design document. And then I have another design document where I've defined 2 more MapReduce functions or views. What design documents are, in terms of resources within the Couchbase server, are indexers. They are a verb, right? They are, it's a definition of things to be done, and we allocate resources, threads, and CPU time, on those threads for indexing. So this is, design document is an indexer. It's indexing. And that's one way to understand it. What I've defined is 2 different processes that are indexing documents. The views are nouns. They are the indexes. They're what are being produced. And you're defining a view as a MapReduce function, but you're querying an index in that case. So the indexer is the design document. The index itself is the view. And that's what you're querying. It's important to understand this so that you understand how you're distributing resources within Couchbase. If you have 1 view per design document and you have 12 different design documents, you're allocating a lot of resources to indexing, but you may not be using your resources well. It might be better actually to group into fewer design documents so you have less resource requirements. But then on the other hand, going the other way and having 1 design document with 12 different views is also, not using your resources well. Having sort of a balance and even spread of design documents to views is generally what is recommended. The other thing that's important is when an indexer is updating, it is updating all the indexes that are defined within it. So all the MapReduce functions and views that are defined within a design document are going to be updated at the same time. And this is for efficiency in terms of our process in Couchbase server, to make things more efficient, to make things faster, we group things and allocate processes, within the design document. And then when it is doing its work, when it's doing its indexing, it's going to update them all at the same time. It's going to do its work and say, I have 3 different things that I'm supposed to be indexing. I'm going to do them all right now. And of course, these design documents are per bucket. So if you have multiple buckets, you're doing things in multiple buckets, and there's some good reasons why you may want to do this. They can only access documents within the bucket in which they are defined. So, like I said before, every document passes through the view map functions. So this is what the anatomy of a map function. You were passing in, the indexer will pass in the JSON document. It'll pass in the metadata, which can be used actually within your JavaScript function. The emit is like creating a row. That's one way to understand it. You're creating a row. The first parameter is the first column, or your primary column. Since we're all familiar with relational paradigms, it's easy to understand it this way. It's actually a B tree, but we can understand it this way. We're creating a row. The first parameter is the index key. It's the primary column that we're going to be querying. And the second parameter is any output values that we also want to include in our index structure. Like in the beer example, it was the alcohol by volume of that beer. In this case, I'm outputting, the email address. I'm looking up my username and getting an email address. An important thing to remember, and this is what I was mentioning earlier, is that this output value is being included in the index structure as well. Now, one mistake some newcomers make is they actually output doc in this structure. Now you're actually doubling your storage requirements because you're already storing your document on disk, and then you're also storing an eventually consistent copy of that document in the index structure, which is its own structure on disk. So that is very highly unrecommended, discouraged to actually output the entire document as a value of that row, right? So you don't want to make a duplicate copy that's eventually consistent in your index. What you do want to do is think about what particular value you may need in this index. Like in this case, I want to do the document email, and I don't necessarily need to retrieve the document itself just to get one field. In this case, I don't mind putting it in the index structure itself. And I also know that I'm not going to have any consistency issues because this is not something that's going to change often. So here's a sort of single element key. So in this case, what I want to do is query, the email address, and it's a string-based key. And I also want the user's points as a value. And so on every row here, or every node in my B tree, every row, I also get the document ID. So I actually know the document ID for every row. I don't have to output the meta ID. It's included in my view results when I query it. So in this case, I'm querying doc.email, and I also get the value of doc.points, the current value of doc.points. And here's what's called a compound key. And this is a built-in function that we created. It's called date2array, and it's a very convenient function for views. What it does is it converts timestamp values into an array of values. So in this case, the date2array timestamp is actually decomposing the timestamp into an array of year, month, day, hour, and minute. And I can query that, and I actually can group by and query. I can say I can get everything from 2012 or 2012 and October 2012 or October 9th, 2012. I can group by those values using a group by query. So this is a specific type of, it's what we call a compound key. So when I say key, I'm talking about the index key. So I want to go back to the anatomy of the view real quick. Oops. Let me actually get out, go back, that's animation's too long. So the index key is this first parameter. I think this is also important to understand. I know I'm saying this stuff over and over because it's important concepts to understand. This is the key in your index. It's not your document key. This is your key of your index, your first primary column of the row, and then there's the output value. And it's important to understand that this is not necessarily the document key. This is the index key. It's what you're going to be querying by. So this is the array-based key, a compound key, and the last one was the text key. So let's look at some query parameters. So we can parameter with these parameters. Remember, we're talking about the index key. You know what it is we're outputting in the map function. So key equals is an exact match. If I'm looking for an exact, like if I'm using usernames, I'm looking for an exact match on a username. I can query with key equals and the username. If I want to do a set of index keys, I can use an array notation and actually match on a set. And that's the equivalent of where equals and multiple values with SQL queries. I can also do a range of start and end, and I'll show you an example of that. And I can do a start and end based on the document meta ID. And stale equals false allows some control over indexers, and I'll talk about that more in a little bit. And then the group and group by to do aggregate grouping and reduces. So here's this is the most common queries are actually range queries. So I want to get values between I want to get this group of values within my index. In this case, I'm doing a start key of B1 and ZZ, and I'm index keys that match between those two values. And then I have if I change that, now I do only to ZN, and I get that range between those two, between BZ and ZN, which doesn't include the last part. This is important because I'm going to talk about our collations in a minute. So index key matching, this is where key equals a particular value. And then this is the sort of set notation, array notation, where it matches multiple values. Now, one of the things that's important to understand is that our views use a different type of collation than byte order. So in programming languages, almost always, the byte order follows, numbers are less than lowercase a to z, which is less than uppercase a to z, and in terms of the byte value. And that in almost all programming languages use byte order for comparison. In our case, we actually use a different notation. It's called Unicode collation. And that's where actually all the lowercase letters are and variants are less than the uppercase letters and variants, which is less than the next letter. So that means that creating a range between letters is actually easier. If it were byte order, in order to do a query between A and B, I would actually, including capital, case insensitive, I would actually have to do two queries between lowercase a and lowercase b, and then between uppercase a and uppercase b, and merge the results together. But in Unicode collation, I literally can go from lowercase a to lowercase b and get the entire range, including all the uppercase a's and all the lower and uppercase variants, a's with accents or modifiers on them. So this is actually much more convenient, but it's also important to understand if you're thinking in byte order, you'll might make mistakes in your sort of range queries in terms of the letters you're using to query. So that's where it shows the if you look towards the bottom with Unicode collation to get between Y and uppercase Y, you can make the end key Z and then also be non-inclusive of the end. So that means I'm getting the entire range of Y values. So all users that have the, start with the username, beginning with Y. So stale is an important parameter to understand. As I was showing you the architecture, it is processing once documents get on disk, it's processing the documents, it's indexing those documents in batches. So what controls that batch processing? Uh, there are two different ways. One is through the automatic triggers within Couchbase. We have a time-based one, which is 5 seconds by default. We have a number of operations one, which is 5,000 operations will trigger a batch index. And these are both configurable. Those are configurable parameters within Couchbase. You can change the amount of time between indexing batches, or you can change the number of operations that will automatically trigger a batch index. Or within querying itself, using the stale parameter, you can tell the indexer what to do. So there are three different possibilities here. Stale equals update after. So basically that means that after you return the results to this query, index the next batch of documents that have not been indexed since the last time you ran. Stale equals okay means that it will only the next batch of indexes will only be triggered by the automatic set of parameters in Couchbase, the automatic triggers, which is time and operations. It means that don't go ahead and index the next batch. Stale data is okay. And then the last one is stale equals false. What this means is for any of the documents that are currently on disk that have not been indexed since the last time you ran your last batch, index it first, then return results to me. Now, what's important to understand about stale equals false is that if you do this for every single query, you're going to add latency to your application because you're going to be waiting for indexers to return results after they've indexed, after they've done their work. So it's important to understand these three parameters and how to use them. Update after is the default. After you return results on this query, go ahead and process the next batch. So if you insert a document and it hasn't been on disk yet, and you want to make sure it is included in the index, you're going to have to do an update after and then query again to see if it's in the index. Now, if it hasn't made it on disk yet, if you have a high volume of operations, or you do your CRUD operation, your create operation, immediately query, there be a time delay. That's why it was important that I explained to you the time delay between time 1 and time 2. It has to be on disk before it gets indexed. So this is where new users kind of find that they don't understand what's going on. I created this document, but it's not in the index yet. Well, that's because it hasn't made it on disk and gotten indexed. So you have to understand you can do a stale equals false, but even then, if you do it immediately after your create operation, it may not have made it to disk yet, in which case, even if you did stale equals false, it wouldn't show up in your index. So there is a time delay. You can use what's called store with observe, which I talked about in Couchbase 102, which will tell you that, hey, this has made it on disk, and then if you do stale equals false, you'll guarantee that it's in the index. But often, it's understanding. If you understand the architecture, you'll use indexes appropriately. That's why key value patterns for users is actually more useful than using views, because you're going to get that immediate consistency. If you're going to look up by email address as the document key, as soon as you create it, you can read it. And it may take a little bit longer before it's in the index. So I want to stop for a little bit and see if there's any questions that I can answer.
Yeah, we have a couple of questions. Before we go to them, I just want to remind everybody that tomorrow we have our webinar on Couchbase Lite, the mobile version of Couchbase and the mobile strategy of Couchbase. So you're still in time to register. And the second reminder is that this session is being recorded. And so if you have missed the initial part or you want to see the slides, we're going to send an email tomorrow. So we have a question from Sean. Are the indexes held in memory?
They are not. All indexes are on disk. And that's actually the case in almost all database systems, is that indexes are on disk, and we're no different in that regard right now. We've been talking about ways Obviously, it's important to us to reduce the time of eventual consistency. We are definitely in the process of discussing all different kinds of options, and we've been discussing it for a long time. It's quite complex in a distributed system to do this, you know, in memory. But I think it's one of the things that's sort of on our list of how to figure out how to do something like that, how to do it in RAM as well.
Perfect. Thank you, Justdeep. Another question from Alexander. Do you have any best practices for design documents? For example, how many design documents in a bucket, how many views per design documents, or any other advice?
Yeah, it varies a little bit. Some of the advice I can give is that having an even distribution is good, so that you don't have six views in one design document and one view in another. However, it's really more about what the views are indexing. If they're indexing, it's generally better to group things that are updated often. So every view within a design document is going to be updated at the same time. So if you have some views that are indexing data that doesn't change as often, and then you have other views that are indexing data that changes very rapidly, it's good to kind of group those two together in their own design documents. So highly updated data and should be grouped together with other map functions that are also indexing highly updated data. Um, Group those into their own design document because they're going to be updated at the same time. And then for data that changes really slowly, group those together in their own design document.
Great. Thank you, Justip. So let's go back to the presentation, but we will have 10 more minutes at the end for other questions. So please keep using the chat box to ask your questions, and we will cover them at the end of the presentation.
Okay. So we have a few built-in reduces. These are faster than creating your own custom reduces for the same information. We have count, sum, and stats. Count obviously gives the number of items in that index. The sum will sum the numeric values of the output value, the second parameter of your emit statement. And stats will actually do both of those, plus do the min and max and the sum of squares for statistical analysis. And these are actually built in Erlang, and they're going to be faster than creating your own custom reduces for this same information. Custom reduces, and people do ask about this a lot, they are tricky at first. It's its own skill. I do highly recommend reading our docs thoroughly about custom reduces before trying to do it yourself. We do have some examples in there of custom reduces. It's one of those things that sort of advanced and takes some time to understand. One of the biggest mistakes that people make when they're writing their own custom reduces is that they're not actually reducing data; they're increasing data. And that's where it kind of gets, it's a recursive function, and as some recursive functions can be quite tricky sometimes to understand at first, but they are actually very powerful, very useful if you understand it. But one of the important things in this, when you're experimenting and trying to learn how to make your own custom reduces, um, is to do it in its own design document. That way, you will not interfere with your existing views if you have some logic or errors in that view. You will not interrupt other views within that design document with errors and problems. So if you separate and sandbox it out, you can experiment without interrupting your existing views, and that's what I recommend in general. Actually, I recommend that actually for creating most views is that when you're creating it for the first time, separate it out into its own design document so that you're testing things out in sort of a sandboxed environment. And then once you know that it's working and it's doing what you want it to do, you can copy it into another design document that is based on the advice I was giving you earlier, the grouping them together or whatever you want to do. So test it out in a separate design document and then copy it over when you're done and delete your little sandbox. And that's just sort of a kind of best practice way of doing things, is kind of sandbox when you're in development mode, to kind of when you're figuring things out, so that you don't confuse yourself. If you have an error in one map function or reduce, those errors can affect the indexer if it's a major error. But of course, we're working on an update that actually will change that so that even if you have an error in one, map function within the design document will not interfere with the others. And we're talking about fatal errors, not like logic errors, some other major problem. Um, so, so I'm going to talk a little bit about the sample view, and then I'm going to try and give you a quick demo of the interface and talk through that. So here is an example document. On the left side, I have the meta information. This is like a document key. And then within the JSON document on the right, I have the alcohol by volume, and then I have the brewery ID. And those are important for the map function that I'm going to create. So here's my map function. If the document.type, if there's a JSON key, type equals beer, and it has a brewery ID, I want to emit that brewery ID. I want to look up things by brewery ID, and I want to have the document alcohol by volume. So for every beer, I'm going to output the brewery ID and that beer's alcohol by volume. So I'm creating a row here. My index key is going to be the brewery ID, and this is my output value, is the alcohol by volume. So this is what the results look like. And actually, our beer sample has been updated, but I chose this. This was our old document keys and brewery IDs. I chose this on purpose so you can see sort of a cryptic one. We actually changed our beer sample to have all names that are readable. Which is you can see if you install and we're going to look at this in a minute in the demo. We changed how our IDs work so they're human readable, but I wanted to actually show a non-human readable example. So these are all brewery IDs, some sort of generated IDs, and then on the right side you see the alcohol by volume, and then you also have the document key. So that was the beer document that had that alcohol by volume and that brewer ID. And that's included with every view result. Here I'm going to use the built-in stats reduce. And I'm going to query this. And on the next screen, this shows it a little bit bigger. I'm going to query this. And I'm going to group them together. So it's going to group all the index keys that are the same. So those were the brewery IDs. And then it's going to reduce that data and give me the stats. So see here, the brewery IDs are grouped together, and then my stats are computed on those groups. And what I have is like the number of beers for each brewery ID, the count, the sum of the alcohol by volume, the minimum and maximum alcohol by volume, and the sum of squares. So now I can actually calculate the average alcohol by volume per brewery. So if I just take the sum of the alcohol by volumes and divide it by the count, I have the average alcohol by volume per brewery. So kind of I don't know if that's actually that important, but I can kind of get a sense for how much alcohol each brewery produces on average. But this is important to understand. What I've done here is I've grouped and reduced the data with a reduce function that allows me to create aggregate information on that group. All right, so I'm going to give an interface demo for the rest of the time, and then answer any questions we've got. So let's go to my browser. So here I just copied Couchbase over to applications folder. Let's do a quick setup here. All right, I'm just going to take the defaults. I actually want to use the beer sample. And I don't need all that. I'll just make it 2 gigs. I always do these options. Since this is a demo, I don't need this. Put in password. Here's my Couchbase cluster. Now it's installing the sample application, sample data and views. Oh, sorry, this computer is really old and really slow. It's my webinar computer. Did I crash Safari? Okay. Go to views. Hello. Guess it's still loading the data and the views. Okay. Let's change the bucket to beer sample. We've got some production views. So let's talk about this interface really quick. So development views and production views. Development views are basically a sandbox as well. So here I'm going to create a design document. The design document, let's just call it, my beers. And then the view, I'll say by name. So I'm creating a design document, my beers, and then here's one view, and I can actually add another view, let's say by zip, or by country. By country. So now I've created two views within the design document. Now these are not published, so what they are basically sort of a sandbox. So let's look at this view. Here's a sort of random document here. And this is a sandbox, so let's just kind of talk through the interface. Here is where my map function is. This is where the reduces are. Here is sort of a preview of a random document, so I can, keep clicking this and get different documents. All right, so I can kind of get a sample of different documents. The map function is, like I said, is here, and then down here is sort of a way to query those results. So let's, this is just basically emitting the document ID, which is not very useful as an index since I already have that. But here's a list of document IDs, and what it's doing is it's running this within the sandbox of what's called a development time subset. What this is sort of a, we take a sample of data across the bucket and we use it, we apply the map function to it and output the results. We can, when you have like 1 million documents or 40 million documents within your Couchbase bucket, you don't want to run your map function on all of it just in this interface just to test it out. You want to do it on a sample, but then you can, hey, I think I like this MapReduce view. I think it looks good to me. I'm still within development mode, going to run it on the full cluster data set here. And what it's going to do, it's going to take a second to actually show results. It's going to run it across the entire result set, and you see that the results are a little bit different here. It's including more stuff here. And this is, basically my sort of development mode sort of operations. I have a smaller subset, the full cluster data set, and now I know, hey, this is actually a view that's, this is the way I want it, this is the information I want. So now I can go back and I can publish this design document. When I publish it, it goes into production views, and this actually creates the actual indexes on disk, and it'll, obviously continue to maintain that incrementally on disk as documents and CRUD operations are happening. So this is the actual indexes as your production views, right? So I have two design documents, the ones that came with the beer sample, which were these, and then the ones that I just created here. I can copy them back to development mode. I'm confirming that I want to overwrite my development mode view, a design document with these two views, and then I can modify it. I can say, doc.name instead. Show the results. Okay, that's what I want. I want to search by name, and then now I'm going to publish this back to production. Now it's going to warn me, hey, I've already got a design document with that. So now if I publish on top of my existing design document that exists in production, what it's going to do is re-index my documents with these new definitions. So you're starting it over. You're saying, I'm going to change the definition of my view, and I'm going to publish this design document, this sort of indexer instructions to my production mode. And that means I need to create a new index because I'm redefining what this index should be. Okay, so this is production views. So let's look at a couple. So this is in production mode. I can show the results. Notice I don't have development time subset or full cluster data set. I'm actually querying the production mode ones, which includes all the data in the index. So this is, you know, this view is brewery beers. So it's basically doing a switch on type and aggregating together the brewery and the beers for that brewery. So like you can see, it starts with the brewery itself, and then it's brewery and the beer, brewery and the beer, brewery and the beer. Uh, right. So we can actually list out all the beers for a particular brewery. It's sort of like a join. It's the equivalent of a minor join in a SQL query is by I can aggregate all these together. So you can see these are all the beers, all the keys here, and I can actually do a reduce if I want into account. Oh, but I'm in production mode, so I can't modify it. In order to modify this, since it's not defined here, this design document, you need to copy it back to dev. Let's go ahead and copy it back to dev. So now I'm in development mode. Here, I can modify it. So, count. I'm going to add a reduce to this. 96. 96 beers here. And now I can change the query parameters. Let's do 1, 2, 2. I believe that'll capture the 21st Amendment beers. No. 21st to let's just say 31st. Sure. And actually, I'm gonna not reduce. I just want to see the results. Oh, maybe I need to do on the full cluster set. Oh, sorry, I haven't done this one actually. 21st wasn't it 21st Amendment? Um, well, actually, it looks like what I can do is actually, if there's questions while I'm figuring out my own query, I can answer questions for you, Franco.
Thank you, Jasdeep. Yeah, we have a few questions coming in, so we can start from those. A question from Andrea. Can you hide the meta ID for a particular view at the interface level? Do you just eliminate it from the map function parameters?
Can you ask that again? Sorry.
Yeah, sorry. Um, can you
Can you
hide the meta ID for a particular view at the interface level?
you mean the document that generated that row? Can I hide the key? I'm not really sure why you would want to do that, but no, it's included in the view results.
Okay, thank you.
By default, and it's also passed into the map function. Those document keys are important. If you're querying, you're going to need that document ID in order to get the document.
Perfect. Thank you, Jasdeep. Another question we have is, are the indexes automatically distributed across multiple nodes? Can you place indexes only on certain nodes for performance reasons?
No, because your documents and data are distributed across all the nodes evenly, because the hash distribution, which I talked about in Couchbase 102, all the indexes are also created on each of those nodes as well. So when you're querying, it's basically distributing query across all the nodes within your Couchbase cluster, and then aggregating the results and returning it back to your application. So the indexes, this is actually one of the feats of pretty awesome feats that we accomplished with Couchbase 2.0 is in a distributed environment. How do you index across a distributed environment, do queries and aggregate results across a distributed environment, which was a major accomplishment. It's a very difficult task to do. So yes, there are indexes on every node within your Couchbase cluster because your data is distributed on each node. and you don't necessarily know which document is on which node, to be able to group them into a particular node and then index them there.
Great, thank you.
Okay. Okay.
I don't know if you want to move with the other questions, or we can complete the presentation, the demo, and then finish respond to other few questions.
Yeah, I'm not really sure what I'm doing wrong in my query here. I thought this was actually right. So anyway, I'll have to see. I'm probably doing something dumb that I can't realize right now. So yeah, that was actually basically it. And I want to kind of put my information back up. If you guys have any questions while you're playing with views, feel free to send me an email, and or hit me up on Twitter, and I'm more than happy to answer any questions. We are also on IRC, and most of our developers and engineers and SDK staff are on IRC as well in the Couchbase and libCouchbase channels. You can always ask questions there as well, which I forgot to mention in the other webinars. We do hang out on IRC quite a bit, and a lot of people come to us and ask questions there. And feel free to send me an email anytime if you're trying to work out a view or an index and you have questions and you're running into stumbling blocks. I'd be more than happy to help you.
Okay, we can answer a couple of more questions live, and then again we will follow up offline to those that we are not able to cover during this session, and or you can contact us directly at justdeep@couchbase.com or webinar@couchbase.com. So a question from Mark: how do you recommend saving MapReduce function to source control and deploying them to 4 different environments, for example QA, development, and production? Can this be scripted?
Yes, all our SDKs support publishing design documents via programmatically. They're basically JavaScript. It's basically a JSON document actually with JavaScript in the fields. And there's examples. If you look at our sort of getting started tutorials in our docs, there's examples of that. Let's see if I can. I know the Ruby one has lots of examples of with the Ruby model. It shows, yeah, how to include design documents and transmit them. But yeah, it's basically submitting your design document through the API. You're publishing it, and then it'll index. And so yes, you can script that completely through all those processes. Of course, you're going to want to play and define those first before you do them programmatically, and the interface is actually great for that, for defining those things first. So,
Perfect.
so
Thank
here,
you.
like in the Couchbase model gem, you can see that he's got Reduce.js, and he basically is provided a mechanism to automatically publish these, if they've been changed.
Thank you, Justdeep. Yeah, we are running out of time. We have space for one more question.
Okay.
So you mentioned before that you can also use key partners versus instead of indexes. When will you use? Can you have a short answer for when will you use indexes and when will you use key patterns?
I think if you need like immediate consistency, and you are able to use key value patterns or key patterns, you should use key patterns. Key patterns basically involve binary operations or CRUD operations or primary operations for Couchbase. And if you can use a key value pattern, you should use a key value pattern because those binary operations are going to be faster than view queries just by default, because of their sub-millisecond type operations, and they're view queries over HTTP of larger result sets. They're coming off disk. They're not coming out of RAM. So, binary operations will be faster. Views are, very powerful things. These MapReduces you can do a lot of things with, and there are a lot of things that you can't do with key value patterns. This is where the views cover a lot of use cases that you can't do with key patterns. So I think where you can use key patterns, you should. And if you have a use case that requires a little bit more complexity, and you can satisfy that with a view, then you should do that. So I think that that's sort of the the way I generally think is key value patterns first. If I can't do that because this is not something that can be encoded into a key pattern, I use views. And then there's also Elasticsearch integration is your sort of final thing. If you want full text search across any of your fields and you want to do all the powerful things that you can do with Elasticsearch, sort of grouping and filtering and all kinds of interesting stuff you can do with Elasticsearch, very powerful. Then you do the Elasticsearch integration as well. It's a very similar pattern. You're querying Elasticsearch, you're getting document IDs, and then you're doing gets on those documents to actually, use them, display them in the interface or do whatever it is that you need to do with the documents. So, full text search is with Elasticsearch, and then you've got these MapReduce views, for your indexes, and then you have key patterns. So I think that they kind of evolve from there. Key patterns first, binary ops, then view queries, then Elasticsearch.
Thank you, Jasdeep. So we are running out of time for this session. Just as a reminder, we have a short survey at the end of the webinar that you can fill out just to let us know if you found the session useful or how can we improve it. Since this is going to be something that we do every week, we will restart on Monday with Couchbase 101, and then we will do every Monday and Thursday Couchbase 102, 103, and 104. So I hope to see you all next Monday at Couchbase 101 in case you haven't participated last week. And thank you for joining us today, and I'll see you next week. Thank you.
All right. Thank you.